full moon at night is crazy bright. In fact, it's something like 6 times brighter than a half moon because of the way the laws of reflection work.
Okay.
You think it'd only be like twice as bright? It's like even brighter. On a moonless night,
For centuries, humanity has looked up at the moon, captivated by its glow and the mysteries it seems to guard. Despite all of our advancements in space exploration, one part of this celestial neighbor remains shrouded in secrecy, the far side of the moon. Often called the dark side of the moon, this hidden hemisphere has fascinated scientists and dreamers alike. But what secrets does it truly hold? With cutting-edge technology like the James Webb Space Telescope,
What has changed in terms of our understanding? The Webb in the million-mile orbit, or however far away it is, for how long now?
Well, it got there, and then we did some engineering. So I guess a year and a half. Yeah.
And what has changed in our understanding?
So that's been people's first question. And what I want...
and modern lunar missions, we're now beginning to peel back the mysteries of this unseen realm. In this video, we'll dive into the story behind the far side of the moon, exploring ancient craters, potential hidden structures, and what these discoveries could mean for the future of space exploration.
What I want to do is temper that to say something a little different. So, yes, we expect James Webb to make great discoveries. We expect that. But the first order of business is hardly ever, let's discover something new today. It's, here's something that we have limited understanding of, let's improve on that. And in so doing, we deepen our understanding of how things work in the universe. That doesn't always involve overturning a previous idea or discovering something that nobody ordered.
To start, let's clear up a common misconception. The moon is tidally locked to Earth, which means the same side is always facing us. So, while we see one half of the moon all the time, the other half remains hidden from view. This unseen half is often called the dark side, but it's not actually devoid of sunlight. Both sides of the moon receive nearly equal light. The term dark here is more about the unknown rather than the absence of light.
Are these colors enhanced at all by NASA, or is this what the telescope is seeing?
Okay, you want to go there? We'll go there. Let's do this. Yeah. Okay, so in your eye, you have red, green, and blue RGB sensors in your retina. And what happens is, what we define as visible light is the light that comes through and is detected by these three. Those get combined.
This mysterious far side wasn't even visible to humans until the 20th century. While the near side is smooth with dark planes called Maria, the far side presents an entirely different face. It's rugged, filled with craters, and has very few of those smoother planes. Scientists believe this stark contrast results from geological differences between the two sides. The near side has more volcanic activity, leading to lava flows that smoothed out many craters over time. Meanwhile, the far side, with its thicker crust, has kept much of its original rugged surface.
Into a single color image of what you see in your brain.
Okay.
Now, think about that. This entire telescope is tuned for the infrared. You can't see infrared.
Okay.
But what the telescope does is it can take images in 3 different bands, separate bands of the infrared. Then you hand it an RGB and create a color picture, which is the color you would see if your eyes could see infrared. So it's authentic and
One of the most fascinating questions about the far side is why it evolved so differently. One theory is that it might have been hit by another celestial body, possibly an early remnant from the same massive impact that created the moon itself. This idea suggests that the far side could hold clues to a cosmic collision in its formation, a hypothesis that could reveal even more about the chaotic early history of our solar system. Our first glimpses of the far side came from the Soviet Union's Luna 3 probe in 1959, which sent back images of this cratered, Maria-less landscape. These images were the first steps in unraveling the mysteries of this hidden realm. Later, NASA's Apollo 8 mission gave astronauts their first direct look, with crew member William Anders famously describing it as a heavily used sand pile full of bumps and holes. Each subsequent mission confirmed that the far side's surface was indeed very different, sparking even more curiosity among scientists. But exploring the far side of the moon poses a unique challenge. Communication. When a spacecraft orbits behind the Moon, it's blocked from direct radio contact with Earth, creating a communication blackout. This issue was particularly significant during the Apollo missions, where mission control would lose contact whenever the spacecraft ventured to the far side. Advancements in technology have since helped us overcome this obstacle. In 2018, China launched the Keqiao relay satellite, designed to communicate with their Chang'e 4 lander and Yutu-2 rover as they explored the far side. Thanks to Keqiao, data from the rover's far side journey could be relayed back to Earth, opening up a new era of lunar exploration. In 2019, the Chang'e 4 mission marked a historic milestone, becoming the first spacecraft to successfully land on the far side of the Moon. Its primary target was the South Pole Aitken Basin, one of the Moon's largest and oldest impact craters, where scientists believe there may be crucial information about the Moon's internal structure and geological history. Data from this mission is already providing invaluable insights into how the Moon's layers might have formed, helping to clarify why the near and far sides differ so drastically. Another fascinating possibility with far-side exploration is its potential for radio astronomy. The far side of the Moon is uniquely shielded from Earth's radio interference, making it an ideal location for setting up radio telescopes. Such instruments could capture faint cosmic signals, allowing astronomers to study the early universe, galaxy formation, and even the mysterious signals coming from distant stars. Imagine a future where the far side of the Moon hosts observatories, giving us a clearer view into the vast, distant corners of the cosmos than ever before. Our ongoing exploration of the far side brings us closer to understanding not just the Moon, but also the history of our entire solar system. Future missions, like NASA's Artemis program and the planned Lunar Gateway, are set to establish a lasting human presence on and around the Moon. These initiatives could pave the way for lunar research stations that continuously study the far side, enabling unprecedented scientific discoveries. Each new exploration brings us closer to solving the enigma of the Moon's far side. This hidden world serves as a reminder that even the closest celestial bodies still hold secrets, waiting patiently for humanity to uncover them. What makes the far side of the Moon such a compelling symbol of mystery and exploration? Does it represent a frontier that can take us closer to unlocking the secrets of the past and perhaps even the future? As we push the boundaries of space exploration, we may be standing at the edge of revealing secrets held for billions of years by this cratered, unseen landscape. Could we one day discover that the far side of the Moon holds not only clues to our solar system's origins, but also the potential for new science that can redefine our understanding of the universe? And as we venture further into the Moon's shadowy frontier, does this suggest that there's always more to find when we dare to look beyond? Let us know what you think. What mysteries do you believe are hidden on the far side of the Moon? Comment below with your thoughts, and don't forget to like, share, and subscribe to stay updated on more fascinating discoveries.